is Sybex Atari 8-bit podcast.
The first 5,000 books sold out mail order within a few days. So it was clear that there was more interest than we anticipated. She said, "There is a computer in this machine?" I said, "Yes." And she went out screaming and never returned.
This is Antic, the Atari 8-bit podcast. I'm Kevin Savitz. Rodnay Zaks was the founder of computer book publisher Sybex Books and is the author of many classic computer programming books, including 6502 Applications, which came out in 1979, Programming the Z80, Advanced 6502 Programming, and 6502 Games. He also wrote or co-wrote Programming the Z80, Programming the 6809, Your First Apple II Program, Programming the Apple II in Assembly Language, and many other books. This interview took place on October 14th, 2016.
I arrived in Berkeley as a graduate student in 1967, and I was able to get a research assistantship to support myself the next year. And I was lucky enough to get into a research project at UC Berkeley called Project Genie. Project Genie was one of the very few research projects at the time that had ever had commercial success. It developed a time-sharing system that became called the SDS, later called XDS 940, and it actually worked. The mass storage was a drum that would remain alive for periods of tens of minutes, sometimes an hour, sometimes even longer, but it worked. And the project was populated by very bright people. It also was a node of ARPA, which later became DARPA, and as you know, the network became later called, instead of ARPANET, became the Internet. Mm-hmm. So it was a fantastic environment, both because of the technology and because of the people that were there. I still remember the chess-playing program that had been developed by Bo Löwendahl, who later became a minister in Finland. And playing against MIT, it was cheating by moving a pawn if nobody moved for like 5 or 6 minutes. Very interesting environment. So let me get back to the main point. I was lucky enough to get in there. There were extremely bright people: Peter Deutsch, Butler Lumpson, Mel Brittle, Lichtenberger, and many more. And they left about a year and a half or 2 years, a year and a half, I think, later, to create a Berkeley Computer Company, BCC, if I remember correctly, to develop the ideal, relatively low-cost time-sharing system, and even the university invested in it. By the time they left, the project ended, and I moved on to the business school to develop an APL time-sharing system from scratch. Used a very small machine, inexpensive, microprogrammable machine called Meta 4. Worked on it. There were really only two, maybe let's say 2.5 programming employees. I was in charge of the project, and the work was extremely difficult because the concept was to microprogram the machine to implement a core set of APL instructions as well as the operating system, so that this relatively small machine could run a full APL using standard memory. This gave rise to a number of issues, in particular memory management, and the dynamic memory management system needed to be created and so on. So I worked on this. It became the topic of my PhD thesis. But one of the interesting points about it is that the project never had enough money to pay people. So we couldn't afford, or there was no money to pay a hardware engineer, but there was a lot of resoldering necessary, in particular for the memory mapping system, I needed to create an extra board with a memory for the map that might be called the NAT on a router today. And nobody was available, so I had essentially to teach myself soldering, take a few hardware courses, and I was working there at night, soldering, putting ICs in place, testing memory, and essentially making the thing work. By the time I left, a couple, 3 years later, I went to work for Singer, which at the time was mostly known for the sewing machines, but was one of the larger military contractors. I went to work for Singer Link. The Link was the aerospace division and included the nuclear simulators, the nuclear center, nuclear generators, not the weapons. And I went to work for one of the low-tech companies, which was traffic control systems, the traffic lights at intersections. And my responsibility was to computerize them because it was beginning to bid for computerized systems. A computerized system at the time meant installing a full mini-computer at each intersection, connecting those in the network, and praying that the whole thing would work.
Wow.
It was an enormously expensive proposition. Networks were not really, the protocols for networks were barely developed at the time. Essentially, it was enormously expensive, didn't work, and also the devices needed to be located inside the boxes at every intersection. So you can imagine with the type of usual maintenance what that meant into rain pouring it, cold, and lack of insulation. It was, for a technical person, it was nonsensical. So I started looking around, and I discovered a tiny company nearby. I think it had a dozen employees. It was called Intel. Looked up with their marketing person, Bill Davidow. And after looking at them and others, I decided they had a calculator chip that I wanted to use and built a system around, which was seemed like a very simple task. Unfortunately, they wouldn't sell a microprocessor. It wasn't called microprocessor. It was called a microcalculator early on. They wouldn't sell it. They used those to manufacture the vector table calculators, and they had no interest in a low volume. Singer being Singer and a major military contractor, they at least were willing to listen, even though my total requirement would have been in a complete system for maybe 15 or 20 of those. So the short story is they said no. And I went to the local drugstore called Fry's. And Fry's at the time was nicknamed Chips and Chips because you would go there for lunch and buy some potato chips. Or you could also buy the chips from local manufacturers that they had on a small carousel. A presentation, the rotating display in special plastic bags in quantities of one. I assumed that they were buying them in large quantities and repackaging them. So I was able to get a chip at the time. It must have been I'm trying to remember if it was an 8000. Yes, it was an 8008. No, was it? Yeah, I think it was.
Okay.
And decided I would try to build around that. Went back to Intel, said, look, I have a deal for you. Or rather, it wasn't it was Bill Davidow who said, because I was insisting, listen, we're not going to sell you the microprocessor chip. We don't sell it. And we're not in the business of microprocessors. However, if you will buy enough memory chips, it will give you the calculator chip. I said, that's a deal. So I decided to build a system around it, eventually designed a system which was to be used for the town of Pueblo in Colorado that Singer was bidding on, and they got the bid, and I got the authorization from them to publish a paper which must have come out in 1973, I believe, on a microprocessor-based traffic control system for a city. And I was told that it became the first publicized application, the first description of a industrial microcomputer system, and clearly that elicited a lot of interest. And to cut a long story short, I started at that time delivering training seminars to engineers in Europe, in the U.S., and progressively all around the world to train engineers in the new technology, as there was an enormous surge of interest. At the time, managers were uniformly turned off. They thought this was a hobbyist kind of thing, childish. I was also very young, and so were many of the people involved in this kind of adventure. So engineers, by contrast, could see the potential of the digital technology and were extremely interested in just about every country that had technology available. I started delivering seminars in a great many locations, and the interest was surging. In 1976, I created my own training company, Sybex, and for the first year or two, it was only and intensely seminars, training seminars all over the place on microprocessor technology, in programming microprocessors, hardware design, interfacing, and building this into usable modules and blocks, and specific courses around specific microprocessors, since at the time the big competition was Intel, Motorola, and of course MOS technology, and a few others, bipolar, bits noise systems that were mostly developed for avionics and radar inside airplanes and missiles. The company was created in 1976. The seminars were given all over the world, and the main complaint people had was they wanted more documentation. The only documentation available at the time consisted of manufacturers' manuals that were not the greatest, were not often not usable, and focused on describing essentially the specs, the specifications of the machines, so completely inadequate for technical people and engineers. Started publishing books probably late in 1977, and one of the earlier books were Programming the 6502, 8080, and 6800, among many others. At the time, I had never published anything commercially, so I dictated essentially what was a 2-day seminar over the course of 2 days. Then had it transcribed. I didn't know at the time what editing really was, so I went over the text, correcting whatever glaring errors and doing some proofreading, and had it typeset mostly in my own office, because typesetting at the time consisted of getting sheets of typeset text and then making corrections by gluing the corrections over the paper. As an interesting, as an amusing anecdote in passing, I remember hiring a new assistant secretary in charge of typing some of the text on an IBM Vari typer, a proportional spacing machine. And she came from an agency, was highly recommended, experienced, etc. And she came in, and that was a big machine, a big IBM machine, a giant typewriter. She sat in front of it, and when I said that there was a computer, she said, "There is a computer in this machine?" I said, "Yes." And she went out screaming and never returned. This is a static, and it reminded me of the attitude of some of the managers at the time. But computers were scary. In short, the first books were hand-built, and they were, at the time, hobbyist magazines, Byte, Interface Age, Creative Computing, and very few others, that were read by the small but constantly rapidly growing group of computer enthusiasts that wanted to know about the technology and couldn't find any information anywhere else. And I purchased, in large part, full-scale, full-page ads in those for books, which was unusual. And the books progressively acquired spacey-looking covers, mostly because of the impact of Star Wars that came out at the time, and everybody in the computer groups that I was involved in was aware and a fan of the movie, so that many of the early covers were inspired by this. And the first cover of the 6502 book was a rather demure pyramid, if I remember right.
Yeah.
The next one was a highly electronic, spacey-looking chip seen flying. Mm-hmm. So these were the contributing influences to the early design of the books.
Yeah, the copy I have is of Programming the 6502. I guess it's mostly a green cover, and I guess you could say it's a pyramid. I guess. Sure, if you say so.
Yeah, that's the original one.
Cool.
It might have endured through a few editions.
Nice.
It became so popular that it remained unchanged for a while. And the initial print run was a huge amount, 5,000 copies. The amazing thing is they were only sold mail order. We didn't know about distribution through the chains. We didn't have a sales network through bookstores, and bookstores, for the most part, wouldn't touch computer books anyway. There was no market for these things. And the first 5,000 books sold out mail order within a few days. So it was clear that there was more interest than we anticipated, and more books started being created, and all of the early books were transcriptions of the seminars that I was delivering around the world, and these seminars were fire tested. What I mean is I had been delivering these seminars personally to a very large number of people in many cultures, in many countries, listening carefully to their questions, watching them to see if they were understanding. So the seminars were constantly reworked in terms of making the technology accessible, understandable, and useful to the widest possible range of people. As a result, the books, by the time they came out, were the results of thousands of beta testers that had attended the seminars and asked questions or complained or otherwise contributed to making the information clearer or more useful. And they were received extremely well. And progressively, within the following few years, I became a book author and then a book publisher, which I believe was the historical background you wanted me to give you.
Nice. Wow. So where did the name Sybex come from? Did it have a meaning?
Yes. The problem was to find a name that would be reasonably memorable would be acceptable in several languages, since from the start the idea was to be international. The company was created on the same day in Paris, France, and Berkeley, California, and progressively expanded after that to more countries. EX was associated with electronics at the time, Ampex, Memorex, and so on, and had a connotation, I believe, of both electronics and excellence. Sybex could have been originally written CYB for cybernetics, and this was not available, so it became SYB, and the combination became Sybex. What I did was, while working at the university, at the business school in Berkeley on the APL project, one of the projects that had been done on a very large computer running APL was the search for a new name for Standard Oil, Esso, which became Exxon. And they were searching for a two-syllable name that would be reasonably connected to the earlier name, would be easy to remember, neutral, acceptable in many languages, etc., etc. So the rationale behind the name search is one that I had witnessed for this major corporation close by. So essentially, I threw in a basket the syllables that I thought would have a reasonable connotation with the kind of business that we would be in, threw them into a computer program, and the computer program essentially spat out dozens and dozens of combinations. I favored a short two-syllable name, and afterwards needed to go through it to see which one sounded best, and that was the Sybex was the end result. So it was in part a computer-assisted, not computer-generated, but computer-assisted process.
Oh, very interesting. Cool. All right, so you are selling books via mail order, putting ads in magazines. Was that initial print run of 5,000? I mean, was that, I don't know, was it scary, or did you think, oh man, I'll be sitting on this inventory?
Yes, it was scary because I had no idea how many books would sell. It could be 100, it could be 200. I knew that I could move several hundreds or more through these seminars that I was giving anyway, so it mitigated the risk. And I do not recall what the printing cost was, but on such a short print run with no experience negotiating prices and so on, it could have been $20,000 or more, which at the time was a big investment for a very small company. So yes, there was some trepidation, because it was jumping into the unknown. And as you know, in the book business, the highest risk is inventory. Also, once you put a book out, it always, in the technical field, contains some typos, errors that you need to correct later. So the first edition is very risky business, because if there is a glaring error in there, you need to take back all of the inventory and destroy it. What we did is, there were always improvements or errors into virtually any book published. So at the beginning, we'd print errata sheet that we would insert in all remaining inventory. That's a very expensive process. And if you had to do it more than once, it's not worth doing it. You might as well reprint it.
How many books did you...
How many books did I write myself?
How many did you write yourself? And also, like, how many did you write before you're just like, decided to be a publisher and bring in other authors?
I do not remember the exact number, but I assume, I'm guessing, I must have written anywhere between 6 and 10 titles, perhaps at least, because I remember delivering typically maybe up to 6 different seminars, and all the seminars, nearly all the seminars I delivered became books, with one exception for a military-related one. And there were many variations after that. For example, Programming the 6502 was followed by 2 more advanced techniques and 6502 games. And many branched out. So it might actually be more than 10 over a period of maybe 3 or 4 years. Mm-hmm. And I do not remember after how many years. It might have been 3 or 4. I definitely wanted to publish titles that I knew I would never have the time to write and therefore needed to hire authors for. A friend of mine who had obtained PhD number 3 in computer science in the Department of Computer Science at Berkeley, and number 2, Rudolf Langer, had become a friend of mine. He worked at the time afterwards for National Semi, and I stayed in touch with him. And I told him early on, Rudy, I will need your skills and your help at the company. Unfortunately, right now we're too small, and I wouldn't be able to afford you and pay an amount that you will consider. However, I'll come back in a year and hope it will go better. And it may have been a little more than a year later, maybe a year and a half, but I came back to him and told him, look, I still cannot afford it, but I will do it. Will you consider moving? And he was happy where he was at National Semi, but he had always had a passion for books, writing. He had never been an editor-in-chief, nor managed authors, but then the whole industry was entirely entrepreneurial, so that was not to stop him, me, or the other people who were part of the early stages of that industry. And after many months of hesitation, he accepted, came on board as the editor-in-chief, and I remember he summarized his mission in the company as putting me out of the author business. And starting to recruit outside authors, which he started doing. So I kept writing books maybe for another couple of years after that on a reduced schedule because I just didn't have the time. But he was very successful in his endeavor, started hiring authors, and that's how the company became a true publisher rather than a single author publisher. And that must have occurred in the late 70s or very early 80s.
Nice.
And then he remained editor-in-chief of the company for a very long period of time until he unfortunately died of leukemia.
Wow. And then Sybex just kept pushing out computer books. I mean, kept moving with the times for years and years. Can you talk about that, about changes, about how, I mean, you went from very technical things like assembly language programming and various languages to, as computers became more general interest. Can you talk about that?
Yes, the company grew with the technology. The technology at the beginning was programming chips with hexadecimal keyboards, not even regular keyboards. Displays that were black and white, and you would display hexadecimal on it. So it was assembly language was already a luxury, high-level language. You may remember Bill Gates' comment that there was 4K of memory on the Altair machine. That's where he designed his basic interpreter. Nobody will ever need more than 4K. Storage. Machines had little storage. They couldn't really implement much of a high-level language except for a micro and mini version of BASIC at the time and a few other computing languages. Over time, of course, the Moore's law made it possible to double the density every year and a half or 2 years, and the technology improved rapidly. We, Sybex, the company, had for a mission to train and help people in that field, and our publication focus evolved alongside the technology. We started with assembly, then we moved on to programming languages, Pascal, if you remember that, BASIC, many others. Then databases, which were a novel thing to put in the hands of individuals and managers, and progressively started covering the entire field of usage of what was still called microcomputers, then became personal computers. And our mission was always to cover the needs of users in the field of personal computing. As the level and the power, as the level of the programming tools and the power of the machines went up, so that our focus of publishing.
Mm-hmm. So how did your job change as you transitioned to publisher and away from not doing the writing directly? What were you doing on a day-to-day basis?
Well, from the beginning, the job was to educate people, produce material, deliver it, at first verbally in the form of seminars, then in printed form as books, but also to manage a rapidly growing organization, and growth was fast. Profitability was non-existent at the beginning, so it was a constant struggle to make the right decisions, hire the right people, create the right structure. And management clearly took an overwhelming portion of my time immediately. As soon as the number of people increased beyond 10 or 12 or 15, within a few years of creating the company, and every few years, a new one was created in one of the key markets. So there was initially France and the US, then Germany, then several years later, Holland, then UK, and to a much smaller extent, Australia. And these were independent organizations that reported directly into me, so the management responsibility became very high between management in the home company in the US, management at the affiliate companies, each one with its own set of local issues and problems, and keeping an overwhelming responsibility in focusing the publishing decision. Traditional publishers at the time, and today things are changing, but for an extremely long period of time, the traditional motto of publishing is you take a title, throw it on the wall, and see whether it sticks. What it means is just like stock picking, you publish 20 titles, and one or two of them will be a success and pay for the failures of the others. We couldn't afford to operate this way, also would not have been interested in operating this way. We needed to manage cash carefully. The company almost never used credit. It was self-financed all along. And that was a dangerous situation to be in because errors could be costly or even fatal along the way. And we wanted every title to satisfy real user need that also had a path to the user. There are many interesting titles that could be published that people would never find because they wouldn't be in bookstores or publicized in places that they look at. So it was a very difficult and complex job to select titles, to define what the contents would be, bring them to market simultaneously with the product, and make them available through appropriate channels. Immensely complicated job. And what's called day and date publishing, where the books are released the same day as the software or the hardware, carries its own dangers because, as you know, software evolves until the last minute, whereas books have to go to print in a number of weeks, many weeks, before they're available. Then they need to be shipped and arrive at bookstores to be available and released to the public in time. All of that under extreme pressure. At the time, a technical book used to require maybe a couple of years longer. And we installed a system whereby books would come to market from the idea to the book on the shelf in sometimes as little as 90 days. So the system was new, different, fraught with risk, and making the publishing decisions as to which title to publish on, what contents to have, what authors should be doing it, and how to implement the process so that nothing would delay publication was extraordinarily complicated, and that's where a lot of my time was spent. When meeting other publishers, typically New York publishers, they were in complete disbelief about the schedule and they just didn't believe that. They assumed that they were being fed disinformation. It was just not possible. But they were right. It was virtually impossible at the time, and it required doing essentially everything except the printing in-house, and managing the process in an exceptionally challenging and efficient way to get to that result. And I remember one of the questions that visiting publishers were asking is, how big is the team working on a book? Is it 2 people, 3 people? I said, no. A book will be touched by 12, 20, 30 people, and most of these operate in parallel teams. Otherwise, we wouldn't be able to make the deadline, and that just didn't register.
Wow.
At the time. So it required a different type of organization that has become familiar today because of the way the internet links people together, but was unusual at the time. So we had some unusual efficiency coupled with the ability or the sense, because the top management, Rudolf Langer and myself, were both technical computer people involved in the technology. We knew who the players were, and we had a fairly good idea what had a chance to succeed and what would not. As a result, we were, for the most part, successful in making our title selection and bring it to market in a timely way.
So you had said before that Sybex was barely profitable, and I assume that at some point it became profitable. Was there a turning point? Was there a particular book or event that turned things around to become more of a success?
It was not sudden. It was entirely progressive. From a simplified standpoint, if I remember correctly, during the first 5 years, we were barely break even, if that. And for the early years that involve, for example, myself not even paying myself a salary, because that was the way things got started in garages at the time. And progressively, once there was a critical mass of books flowing through the channels, and by that time we were beginning to get into bookstores and so on, it had become a regular cash flow and a sufficient one to generate a small profit, which went growing very, very progressively, since we were essentially reinvesting constantly into new product development. And paradoxically, when there was a crash in the industry, which occurred in 1983, after Time magazine made the computer the man of the year, and everybody rushed into publishing computer books, saturated the market. And of course, at the time, there were hobbyist devices, toys. Some of them were used for industrial purposes, but they were not full computers, even though IBM was beginning to come in. And the result was such an overproduction of computer books that they didn't sell during the big Christmas market, and the majority of them were sent back by the chains in large numbers, caused a crash, and that caused a significant slowdown in the number of titles that would be acceptable to the chains, whereas they would buy anything sight unseen before that. That was scary for everyone. It was scary for us as well. But the end result was that the chains finally started to discriminate among publishers and to discriminate among titles. Also, we could slow our number of titles being released to those that we felt we were really comfortable with, rather than anything will sell. And as a result, that established the company after that on a solid track to profitability, as it often happens after an industrial slowdown. Those that were putting mediocre product out or caused the fall in the market often get eliminated at that point.
Mm-hmm. Sure. I heard a very similar story on that period from Mitchell Waite. He
yes, he was a publisher at the same time.
Right. Yeah. So is it time to talk about the company being sold to Wiley?
Sure.
I would like to know that I believe that happened in 2005. Why that happened and how that went?
That's correct. Essentially, there was continued unusual growth through and slightly beyond the year 2000. The year 2000 was the peak in the computer craze and the bubble, where I remember going to my dentist and hearing the receptionist said that she was getting a CCNA. She was getting a Cisco Certified Network Architect certification. And she didn't have any technical background, but it was a badge of respect that people were getting. Such was the craze. She would probably never get ever the use of it, but she was not the only one. And it was like, I have this on my card, and I'm an unusually savvy person. Didn't make any sense, of course. There was, as you know, a huge crash caused by the computer bubble starting in about 2000. And as a result, sales started going down with the market moving towards institutional schools and universities and constantly decreasing at the consumer level, which, of course, meant that the chains and the larger distributors were becoming more selective, accepting fewer titles, getting more margin in various ways and making the business far less profitable, and also limiting the sales for everyone involved. But that corresponded to a decrease in the market. After watching this decline in the computer book market continue for a period of time, I realized that we would have to move in a big way to the educational market instead of the consumer market. And that was not the type of organization that I was interested in running. It would have required a different structure. So I decided the time was right to entrust the company to a publisher in this market. I spoke to several of them and decided that Wiley was obviously the one that would do best and continue it successfully. Sold the company, and they have continued the Sybex brand with much of the original team still in place, I believe, today, quite successfully. So it turned out to be a win-win.
Nice. What do you do today?
I am mostly looking at computer-related companies and investments, but most of my actions are related to investments.
So what haven't I asked you about Sybex, about that time, about those early days that I should have?
That's for you to answer. Clearly, I have a great number of amusing stories, but I believe that your interest revolves primarily around 6502.
Yeah.
So I can give you a few anecdotes relating to the 6502.
I would love anecdotes. I would love that.
Right. I was writing the second book on the 6502 and applications of the 6502. And at one point, I was looking for examples of input-output programming because I was using a couple or three boards that were 6502 based. And I had put a stepping motor on one of them, which delighted engineers to see how you could control a stepping motor with a few hexadecimal instructions on a 6502 board. But that was a very simplistic example. So I was looking for more applications relating to computer devices that I had not personally programmed. So I called someone I had met named Steve Wozniak, and I said, Steve, I need an example or several examples of I/O programming. Perhaps you would have in your code examples of I/O programming, especially within the operating system, such as the operating system of the Apple, that you could let me quote with attribution. But I can explain why this is done and how it's done as a programming technique that has been proven to work, as I only want to publish something that works. And he said, oh, sure. And maybe 2 days later or 3 days later, I received a large box. And in there was the entire operating system of the Apple II. So I called Steve. I said, Steve, are you crazy? This is the entire OS of the Apple. You shouldn't ship that. I just want to focus. He said, take whatever you want. So I quoted a few sections of the Apple II operating system in the input-output section of that book and sent the entire box back to Steve, as I felt personally insecure having an entire copy of the operating, which at the time should have been guarded carefully. Operating systems at the time there were very few people capable of writing operating systems or even that understood them. And if you have driven a car these days, you know how bad an operating system can be. Steve had always been a very, very trusting person. So that's how some of the examples, and there's an attribution somewhere in the book to Steve Wozniak and the Apple operating system, were used to illustrate the techniques that were used to communicate with some more complicated devices. Here is one of the anecdotes that I think relates very directly to the 6502.
Nice.
And another one that relates to the company that you're probably familiar with if you've spoken to other people is that the company was created in 1976, and the meetings or the exhibits relating to computers attracted at the beginning enthusiasts, but very few exhibitors. So they were probably for the first 2, maybe 3 years of that industry, say starting in 1975, they were probably no more than a dozen people actively involved in it, and we all knew each other. And for nearly a decade after that, they were called the Club of the 76ers. That included Microsoft, which Bell incorporated created in 1975, Apple, Sybex, and unfortunately many others were no longer around since, as you know, there has been some mortality in the industry. So it was a group of people where, for the most part, we felt we were not in competition with each other because the field was huge, and we were all helping each other because it was so difficult for most people to use the technology that they needed everyone. They needed the chip manufacturer, they needed the hardware devices, the development systems, they needed the software, they needed the languages, they needed the applications, the interfaces, and they needed the training, education, and the books to be able to put them to use. So it was highly unusual that for the first decade, the entire industry was able to develop with minimal, if any, competition. And I personally was friends with every other book publisher. We competed sometimes on a given title to release that day and date and do a better job. So there might be competition on any given title, but overall, the entire industry was growing the entire field and making it more useful and accessible to everyone. So it was highly unusual. Oh. It's only when the industry became highly visible and IBM stepped in and the floor fell that things changed. And then several of the big players came in and made it a truly competitive and cutthroat environment the way it has remained to this day.
Wow. Do you have any other 6502 anecdotes?
In terms of funny anecdotes, probably not. I can quote another one, which is not 6502 related, but denotes the atmosphere of the times, which is, I would say, around 1978, probably. I was at Intel, and we're preparing books on their more advanced processors, maybe the 8080 or the 8085. And I got to talk to Bob Noyce and others there. And one of my questions was why they were not pushing their development systems, MDS development systems, as say, like to the consumers, because you needed a development system to program a new microprocessor, and they had excellent ones, low cost, but they were not interested. So the answer was, we're not in the microprocessor business and never will be. We are in the memory business.
Right.
And that lasted, I think, for another decade or so until they changed their minds.
Wow.
So the industry evolved, and much of it evolved by accident. And as you know, the 6502 was created a little bit like the Z80 at Zilog by engineers leaving their original design company and doing a better design at lower cost, but aiming it straight at the masses instead of the elite few. And there are those who did particularly well. There was a commonality in spirit in many of the people who got involved in the microcomputer industry, because they started it at a time when they sensed, they knew, they could see ahead that the technology would enable ordinary people to do extraordinary things, not just a select few engineers to implement extremely sophisticated systems, but rather ordinary people to do ordinary things at remarkable speed and remarkably low cost. And that explains in part the success of the 6502, since it was used originally for games and afterwards found a new life as an embedded control system, because that's what it was eminently capable of, given its small size, reduced instruction set, and capabilities. And I believe to this day, it's still incorporated in industrial control systems.
Yes, it is. And pacemakers, apparently.
Well, they should be reliable. That's a good idea.
All right, I think this will... I'm sorry, go ahead.
I'm sorry. As you know, when you send things in space, for example, they have to have been available for 5 or 10 years in order to project 10, 20, 30-year reliability.
Sure.
I wouldn't be surprised if a number of these microprocessors, or rather the part of the chip, is navigating in stellar space as we speak, because it would be one of the more reliable computer designs ever achieved.
All right, I think this will be my last question. This podcast will be listened to by Atari users and Apple II users and other Commodore users and who knows who else, 6502 users. So if you could send a message to the 6502 microcomputing community that still exists, what would you tell them?
That they have made a fantastic investment, because, as I pointed out, the fact that the original chip architecture is still being used today, 40 years later, is truly extraordinary, and one of the extraordinary testimony of design by Chuck Peddle and others, by the group of engineers who designed it originally and managed to create a chip that has a small enough but usable enough instruction set that it can implement virtually any automation function, yet achieves this at ever greater speeds and can be reduced in scale without going bad, and keeps ticking with extraordinary reliability. I don't know that there are that many success stories in the computer industry where a computer design has ever survived for that long. So who knows what it might be used for in the future, since the design itself is an extraordinary testimony to doing just enough in the right way that it will keep performing for an indefinite period of time. So to all those who are looking into it, I believe they recognize the design genius behind it, and at the same time, the relative simplicity that allows one to do so little with so few instructions. I do not remember the exact number, but I believe it's 50 and a few, 58 instructions after they corrected the right rotate that didn't work initially. So a very small number of instruction that survived. The previous Bible used to be the DEC digital equipment, which unfortunately is no longer around because it was not designed to be implemented on a single chip. The 6502 was and remains a design monument to this date.
Thank you so much for your time today. I super appreciate it.
Well, Kevin, thank you for your patience in trying to reach me repeatedly, and I appreciate your interest. Thank you.
If you enjoyed these interviews and would like to contribute something, I encourage you instead to donate to one of our favorite organizations, the Internet Archive, at archive.org. The Internet Archive is a nonprofit digital library with the stated mission of universal access to all knowledge. They've done incredible things to preserve computer history, including hosting thousands of programs in an in-browser Atari emulator, creating the Wayback Machine, and offering full-page scans of countless Atari computer books and magazines. Make your tax-deductible contribution at archive.org/donate.